Good afternoon, students. Let's start our next seminar. So this week, students, we have continued our topic, right? So last week we discussed about choice with risk. And this week also we will discuss about that choice with risk. So last week, students, if you remember, we discussed about expected utility. And then we have seen that because people behave differently, and they see, those risks, measure risks differently. We have said, people, they see it, they overweight the probabilities or underweight the probabilities. And then we try to improve our model with expected utility control for disappointment, right? We have done it. We did all the calculations. And plus, we also considered rank-dependent expected utility function. And we try to explain that LA's paradox, why people choose in one case differently and in the other case differently. So today, students, we are going mainly emphasize on prospect theory, okay? So which is a very famous model, which was developed by Daniel Kahneman and Amos Tversky. Okay, we are going to apply that model in order to explain those people's behavior when there is risk, okay? We are going to explain it. All right. Before I start, because last week at the end of the seminar, we had no time to say a few words about prospect theory, but during the lecture last week, I tried to explain. So prospect theory, students, so this is that prospect theory. So graphically, it looks like this, okay? So this horizontal line represents what? Value of, so on the left side, on the right side, it represents all our gains, okay? On the left side, it represents losses. And this vertical line represents utility. Anything above zero, it gives people utility. Anything below, it gives this utility. And if you remember the curve in the gain side, which is plus side, okay, it was concave. On the negative side, on the loss side, it was convex. And it was looking like this one. All right? So it was looking like this one. So what does it mean, students? Let's suppose I gained $10. Okay? I gained $10. And then this $10 indeed will increase my utility. Okay, let's suppose it increases my utility by 10 if it's 1-to-1. But we said if it's going to be, students, if there is loss, if it's $10 loss, it causes this utility, which is quite large. Okay? So which means that $10 gain in terms of affecting on people's behavior on happiness, and $10 loss affecting on people's dissatisfaction, unhappiness, it has really different effect. Okay? So people, even though the gain and loss is exactly the same, but the effect is very different. Okay, it's very different. So losses, students, when there is loss, people become very disappointed. Okay, people become very disappointed. It was actually what prospect theory is. So today, students, we will be implementing this study, okay, in our exercises. Today we have 3 exercises. The first one is the most important one, which we will start. The other 2 are also important, but not as complicated as the first one. Okay, it's not difficult as last week. The following 2 weeks will be very difficult. Okay, good. So legal settlements case. So it was at the end of the lecture. We have considered. Quickly read, students, if you have not, if you did not have chance to read it. Quickly read. All right, students, I think you were able to read, so that the given. So now we are considering that race discrimination, right? So white person discriminated black person, okay? So we know that in any country, in any society, discrimination, it is not accepted, which is not legal, right? So therefore now that black lady was discriminated by a white person, so now she is now going to appeal to the court. The gentleman discriminated me, so there must be some penalty or some, the certain type of penalty should be issued towards him. So now we are considering students, both peoples, they have wealth of how much? 100,000, right? Both, they have wealth of money of $100,000. $100,000. And now, according to the given, so if she is going to appeal to the court, and if that gentleman is found to be guilty, so there is this much probability, that white person has to pay how much? $5,000. And his final wealth will be equal to? 95,000, right? Because now he has 100,000. If she is appealing and she is winning the case, then he has to pay $5,000 and his total wealth will be 5,000 less. Okay? And we are saying that this white person, he has this much probability that he is going to win the case. She is appealing and he is winning. And if he wins the case, then his final wealth is going to be equal to how much? 100,000. He is not going to pay that $5,000 of penalty. Done. With the white person, now we found this. So now we are asked to write the prospect for white and black. For white person, we wrote the prospect. Good. And what about in the case of black person? That black lady. Now we are saying that there is this much probability that she will win the case, right? He will lose the case, she will win. If she is going to win, it means that she is... So if he is going to lose, it means that she will win. So if she wins the case, what will be her final wealth? Equal to 105,000, right? If she loses the case, her wealth will not change. It will remain the same, which is $100,000. Done. So this is, students, now we are asked to write the prospects for both that white person and black person. Okay? So I think now it is clear. So students, now we will be looking at scenario A and scenario B, where probability of risk is high in both cases. 50%, 50% probability, okay? We are going to consider these two cases and we will try to explain it with prospect theory. I'm not going to do the calculations for this one. You can do it by yourselves, okay? We will do calculations with low probabilities, which is more important. If you understand that one, this one you can apply, you will get the same results, okay? It will be easy. So now let me just, again, draw that curve. So let me draw this curve that so now 0, this is reference point, okay? Reference point here, 0. Not losing or not gaining case. Not losing or not gaining case. So look, scenario A. Imagine you are in the place of black lady, okay? There is a 50% chance that you will win the case and get $5,000. If you write the prospect for black lady, now it shows that black lady now, we are saying that there is 50% chance, 50% probability that she will win the case and her wealth is going to be 105,000. And we are saying that there is another 50% probability that she is going to lose the case and her wealth is going to be 100,000. We are considering this case, okay? And here is the question. And another thing. But now, because that court thing no one likes, okay? Because if you are going to appeal, that court will give you a chance. if you want, you can settle down the issue without going through all these procedures. Okay? You can agree. So now this white person is now offering her, I'm going to offer you 2,500 if you don't go to the court. All right? So now what that gentleman is doing, he's saying that you will have 100% probability of how much? 102,500, right? Now he's offering this offer. Here this is 100%, no risk. You will get 2,500 for sure, 100%. And now in this case, there is 50% chance that she will get nothing. Okay? So look. So now, should she accept it or not? That's the question. Okay? So students, if she is going to accept 2,500, is she going to be on the plus side or negative side? Plus, right? So it means that she will be on this side. Okay? So now it shows that because the curve is concave, so let's say there is 2,500, it is going to be given for her, and it's for 100%, and her utility, look, her utility will be somewhere here, okay? It will be somewhere here. Some value is given, all right? Good. And look, because it is concave, which means that marginal return, it's in terms of diminishing, right? It's diminishing, you know from microeconomics. Now, if there is 50% probability that she can double it, which can be 5,000. So now, if it's going to be 5,000, look, then this is going to be her utility. Does it increase her utility significantly? No, right? So now, students, if people are on the gain side, students, usually they don't want to take risk. Why? Because additional gives only a little utility. But if she loses, that reduction, it will be very significant. So therefore, she will agree. She will agree. Because if that 50% chance of losing happens, there will be this much reduction. But if she doubles, it will make her a little happy. This is it. So therefore, for a little happiness, she will not be taking that risk. Okay, this is on the positive side. It is scenario A. Scenario A. Scenario B, students. Now you are in the place of that gentleman, white person, okay? Now there is 50% chance that he is going to lose the case. So which means that there is 50% chance that her wealth is going to be 95,000. And there is another 50% of risk, probability that her wealth will not change. Okay? That's the case. And now, that lady who doesn't want to go to the court, now she is asking, okay? She is asking. She is saying, if you are going to pay me 2,500, if you pay me 2,500, I'm not going to the court. So what she says is, now you will have 100% probability of 97,500. I will not go to the court. Okay? So now this is the case. Now that lady is asking from the gentleman. So now because this is B, is he on the positive side or negative side? Now he is on this side, okay? On this side. So according to the findings of Kahneman and Tversky, this curve it is convex. Okay? Convex, it looks like this one. So look, now 2,500 here, 2,500, 2,500. 2,500, you can see from here, it causes very large disutility. Okay? Very large disutility. And now he can pay it. But if he is going to risk, okay, now the worst scenario is he is going to lose 5,000, right? And now if you, because it's now convex, it's going to make him a little more disutility. It will increase a little more disutility, it will cause. All right? So students, when people are on the negative side, because this is convex also, it shows people will be risk-loving. They will risk. Okay? In this case, he will not agree. Why? Because now there is 50% chance that he can be on his initial point of 0. He will risk for this 50%. He will risk. So he will not agree in this case. Okay? This is what happens. For example, when people, they are gambling or casino or whatever, all right? Believe me, those people who are losing more and more they are losing, more and more willing they will be to continue the game. It will be the case. For example, I remember when I was, elementary school student, because I grew up in a very rural village. Okay, me and my friend, we had that. I don't know whether today that kids they played or not. We had that metal balls, and we used to if you hit the ball with your fingers, you just push and hit the ball, then you will win. And me and my friend, we were gambling. Okay? If I hit, he has to owe me something. If he hits, I have to owe him something. It was the case. And first time I hit the ball, he was owing me. And he said, and the second time, for example, he was owing me 100. Second time, again, I hit the ball. And it became 200. Then he said, now we will pray for 200. Okay. Then I hit again. Constantly I was winning. And it reached that level, we did not know what's the next number. We were asking, elderly people, what comes after 1 million? What comes after 1 billion? It reached geometric progression. And it was even late night, okay, night is coming. I want to go home, but he's not allowing me. Because I was on this side. He was on this side. At last, he hit, and game was over. Then we went home. All right? So people, when they are at this side, they are very risk-loving. Okay? Why? Because at least they want to be in a situation where there is no loss. I think now it's clear. Okay? So now, students, we will be considering this one here. Calculations we will do. Okay? This one also will be calculated using this one. This will be your homework. You can do it by yourself. Exactly same answer you will get. So, she will accept it, but in this case, he will not accept. Okay? You will get those numbers. Quickly read. All right, so now this is scenario C, okay? We are considering scenario C, case C. Now, imagine you are in the place of that gentleman, white skin. There is 5% probability that you will be found guilty and have to pay $5,000, okay? So now, if we are going to write the prospect, okay, let's say this is prospect 1, okay, prospect 1. So there is 5% probability, only 5%, that he is going to lose the case and his wealth is going to be $95,000. All right? And the remaining 95% chance, there is 95% chance he is not going to lose the case. So which means that he will get his wealth will not change, $100,000. Good? And now, we are saying that the lady, now she is making an offer. If you pay me $250, I'm not going to go to the court. Okay? What she is saying is, now second one, you will have 100%. So for sure, your final wealth is going to be equal to 99,750. So it will be the case. Okay, 100% guarantee you will get it. So now the question is here, would he agree or not? Okay, should he agree or not in this case? Should he agree or not? So now the question, should he agree or not? We have to find it. So students, now we are considering utility function which is given as prospect theory. This is prospect theory, okay? So let me write down this utility function here. So that utility function is given. So now we have 10 in the square root x plus. So our final wealth minus reference point in the power of 0.88. And 10 in the square root of x minus 2.25, reference point minus final wealth in the power of 0.88. So look, what you should know, students, which of these two to apply in which case. So if the case is, so now, according to this, given, what is that gentleman's reference point? Reference point here regarding wealth, 100,000. Okay, 100,000. So it may increase, or here it may decrease or remain the same. So here, student, this R is reference point. Okay, so this is equal to that R, reference point. So students, if final wealth is going to be, so that's given. If final wealth is going to be smaller or equal to reference point, then we have to apply this first formula. Okay? If it's going to be greater or smaller, then we will apply this one. So now you will see. If our final wealth is going to be less than our reference point, then we have to apply the second one. Okay? The second one. So now, students, we will apply it. So look, first one, write the prospects. We have already written. Now we have these two prospects, okay? We have this. Now look, if a person ends up with 95,000, is it greater or smaller than reference point? Smaller. Then, in this case, we have to apply the second one. All right? If he ends up with 99,750, is it greater or smaller? Smaller. We have to apply this one. If he ends up with 100,000, we have to apply the first one. Okay? The first one. Good. Look, given delta equal to 0.69, find decision weight on losses. So now we are considering that people overweight risk. Okay? People are overweighting. Look, here, the probability of losing is only 5%. 5%. But now, even though it's 5%, people may overweight. Last week we discussed it, right? We are considering that one. So now, even though it's 5%, people may see it. I think that it's not, it's larger. Okay? The probability is higher. So now we will consider that one. For that one, first we have to find decision weight on losses. How a person is weighting this 5% probability. So we did first one. Now we will consider the second case. So our delta is given, students. Now let me write down that formula if you forgot. So now, in order to find that weighting, students, weighting of any probability, it was equal to, now, probability in the power of, here, students, it's delta over probability in the power of delta plus 1 minus probability in the power of delta in the power of 1 over delta. That's how we should find those weighting probabilities, okay? This is it. So now we will find it. We know what delta is equal to, and we know what probability is. All right, here. So now if you apply it, so how that person is overweighting that probability, so now our W1, because the first one is equal to, that probability is now 0.5%, so 5% in the power of 0.69. Okay, delta is 0.69 over 0.05 in the power of 0.69 plus 1 minus 0.05 in the power of 0.69, and everything in the power of 1 over 0.69 equal. And if you are going to calculate this one, students, so it will give you the number of 0.11. 0.11. What does it mean, this 0.11? What does it mean? Even though the probability of losing, actual probability of losing is 5%, he is seeing it as 11%. Overweighting. Okay, overweighting. So students, one more thing. There is the probability you will have similar problems in the final exam. Let's suppose you have a similar one. Now, students, let's suppose what is required from you is, if you have to find this weighted probability, okay, then you have to write it very nicely, and just answer will be sufficient. Because the rest thing, anyway, who is going to do it for you? Calculator. It will not be you. You have to enter these numbers correctly. Just get the number, this is it. You don't have to write equal, this is equal to what, 0 point blah blah blah, or this one, no need. But this one is needed. If you just write this answer by looking at your friends, you will get 0. This is what we need, is this one. So 0.11. The actual probability of losing the case is 5%. 5%. It is, statistics shows that it is the case. But people, they overweight. They think that, I think that losing, the chances of losing is much higher. Overweighting, okay? So once you find W1, first weight, because now there are 2 cases, finding the second one is very easy. Second one, because chances will be 100%, right, full? So 1 minus 0. Let me write. Finding the second weight is, you have to subtract from 1 the second one, first one. And it will give you 1 minus 0.11, which is equal to 0.89. Okay, 0.89. This one? Yes, you must, if you have it. Yes. So look, students, now if you would like to find the W2, this one, and apply that formula, you will exactly get the same number. So this one is easier. Okay? 1 minus this one, it will give you that number. Done. And now write the prospects with weighted probabilities. Weighted probabilities. Okay? So now we are going to write that weighted probabilities. So now our prospect with weighted probabilities in the first case, okay, in the first case, is now, he is thinking that there is 11% probability of his wealth is going to be equal to how much? 95,000. And he is thinking that there is 89% probability that his wealth is going to remain unchanged. Okay, 100,000. So now this is the case. All right. So this is, students, in the first case. All right, in the first case. What about in the second case? Because in the prospect 2, if you are going to overweight, underweight, doesn't matter, because it is 1. If we plug that 1 in here, it will be equal to, again, 1. All right, it will be equal to 1. So in this case, students, prospect is here, weighted probability is 1. Okay, W1 is equal to 1. Same. All right, done. Next one. Find expected utilities with weighted probabilities. This is what is the most important thing. I'm not asking you to find probability, that to estimate expected utility with this probability. You have to estimate it with weighted probability. So where weighted probability is this one, okay? So now we are going to apply that formula, utility function, okay? Now it's time to apply it. So now our utility function, students, you all know from last class, the utility of prospects, let's say that the C case, okay, the first one, because it is weighted, right? Weighted probabilities times our utility function of prospect C. Weighted probabilities. So now this is equal, students. Now let me write down it here. Oh, let me just write down here. So this is the formula that we are going to use. And this utility function is equal to this one. And now here, pay very close attention, students. Look, now we are saying that there is 11% probability, right? 11% probability that he is going to lose the case. If he loses the case, what will be his final wealth equal to? 95,000. Is it greater or less than the reference point? Less. Which one are we going to apply? Second one. So now, students, 0.11 multiplied to 10. Now we are applying this one. In the square root, 95,000. 95,000. So if he's ending up with this one, minus 2.25, okay, this is from this formula, times reference point is 100,000, okay, 100,000, minus final wealth 95,000 in the power of 0.88. All right? Plus. And we have 89% chance that the final wealth will be 100,000. 0.89 times 100,000. Which formula are we going to apply? First one or second one? First one, because it's equal. 100,000 is equal to reference point. So now 10 in the square root 100,000, okay, 100,000, plus our final wealth 100,000. It will be 0 anyway, let me write, minus reference point 100,000, okay, in the power of 0.88. So now, using your calculators, you have to find this number, okay?
The second bracket, I think, like because we did probabilities there after the power. Then
what do you mean?
after the power, we should add the second bracket, I think.
After the power. Which power do you mean?
That was 0.88. After we should add a second bracket because we multiplied by the probability there and we get it.
Oh, yeah. Okay. Yes. Okay. Thank you. Right. Because we have to multiply. He means this one we have to have another bracket here. Right. Plus. And here too. Okay. Thank you. Here too. So because we are multiplying it to entire utility function. Good. So students, if you are going to calculate this one, it will give you the number of 2,502. It's equal to, this is equal to 2,702. 2,702.1. So this is the outcome, okay? So which means that person, if he is going to go to court, if he decides to go to court, his expected utility is equal to 2,702. Okay, good. We found it. Now, we are going to find expected utility from second prospect. 99,750 for sure. All right? So let's apply that one here. So again, we will apply it. So now, the second, in the case of second prospect, it is equal to, now we are saying there is 100% probability, okay, 100% probability. The final wealth will be 99,750. Which formula are we going to use? Second one, right? Because it's less than the reference point. So now 10 in the square root 99,750 minus 2.25 times reference point 100,000 minus 99,750 in the power of 0.88. So if you calculate this one, students, you will get the number 2868. 2868.3. If you use your calculators, you will get that number. 2868. All right? Is it clear? So now you can answer the question. Would white skin agree to set out of the court and pay 250? Yes. So now his expected utility from paying 250 is greater than his expected utility going to court. If you have such questions, students, in order to say yes, you must have this number first. This is proof, okay? Let's suppose we have it in the exam, writing yes and no for everyone, 50-50 probability that it will not be counted as the right answer if you don't have these numbers, okay? So now the answer is yes. He will agree and pay 250 because expected utility is larger, okay? He will not go to the court because his expected utility is lower if he goes to the court. I think, students, it's clear.
What about the order? Because the reference point there in the first one, shouldn't we put the 95 first?
No, because this is the formula. If wealth is greater than reference point, then you should subtract final wealth from the reference point.
Yeah, the final wealth was 95, right? I think.
No, now this is applying second one. Because final wealth is less than, okay? Less than. Then you should apply this one. So this one, what you must know is here. The rest is just calculator, okay? If you just make a mistake, so which one should I use? This one or that one? So you must make it clear that you know what reference point is and what is wealth. If the wealth is less than reference point, apply this one. If the wealth is greater or equal to reference point, then you have to apply the first one. Okay? That's the case. I think now we are done with scenario C. Now we have scenario D. The case is a little different. I'm going to erase it. I'm going to erase it. If you would like to take a picture, take it. I will share these calculations, no problem. I have it written, okay? I can take a photo from my notes and share it with you. I have uploaded last week calculations if you checked, okay? Yeah, those calculations I have already uploaded, okay? They are in the intranet system. There is nothing to hide. If you don't know the difference between final wealth and reference point, you will not be able to apply even you see the answer. Okay? So therefore, you must understand the meaning. Okay. Okay, prospect D. So now we are considering that lady, okay, lady. Prospect D. Now there is 5% chance that she will win the case, okay? So if you are going to write the first prospect, now there is 5% probability that she will win the case, and her final wealth is going to be equal to 105,000. And there is 95% chance she will lose the case, and her wealth is going to be equal to 100,000. It will remain unchanged. And now, students, that white person who doesn't want to go to the court, he is now making an offer. He's saying that I'm going to provide you $250 if you don't go to the court. Second prospect. He's saying you will have for sure 100%, 100,000, 250. So for sure 100% you will get this much. Please don't go to the court. So now that person is now making an offer. So the question is does she have to accept it or not? Does she have to accept it or not? So we will be doing now similar calculations, all right? We have written the prospects here. And now, given gamma, now that power of probability is equal to 0.61. One thing, students, now if the case is a loss case, if it's loss case, usually we mark it with that power of probability with delta.
If it's a loss, yes?
Loss. Okay? If it's gain, then we usually mark it with gamma. So in the loss case, delta was equal to 0.69, right? Now we are saying in the gain case, it's now 0.61. Don't worry, if you have these numbers, it will be given to you. All right? It's not something, someone may guess. So now gamma is given 0.61. Now we have to find weights on gains. What we are considering, even though that the probability of winning is 5%. Now that lady, because it's small probability, okay, and the offer is small, now she is overweighting this small probability, thinking that I think that the chances of winning is greater than 5%. Okay, so now we will consider that case. So first we did, now the second one. Our gamma is given for us. Now let's calculate. Now we have to find weight 1 for prospect 1 equal. Probability is 0.05, 5%. In the power of 0.61 over 0.05 in the power of 0.61 plus 1 minus 0.05 in the power of 0.61 in the power of 1 over 0.61. This is why you need a calculator. Okay? So now if you calculate this one, students, it will give you the number of 0.13. What does it mean?
13%.
Even though the probability of winning, actual winning is 5%, now she is thinking her chances of winning is 13%, not 5%. Okay? So now in here, if you now calculate our second weight, how much is weighting this 95, okay? So here, 1 minus weight 1, it's equal to 1 minus 0.13, which is equal to 0.87, okay? This is the second weight. Done. And now, write the prospects with weighted probabilities. We can write it. So now she is thinking that there is 13% chance that she is going to win the case. If she is going to win the case, she will get 105,000. And there is 87% that she is going to lose the case, and her wealth will remain unchanged. Okay? Done. So once we have it, then we are asked find expected utilities with weighted probabilities. Weighted probability with this one. Okay? So let's calculate, we have that formula given, okay? I've erased it, it's here. So our utility for scenario D, that for first prospect is equal to, now we are saying that there is 13% probability that the final wealth is going to be equal to 105,000. Is it greater? What is her reference point? 100, okay? Her reference point is 100. The wealth is 100. So if it's 105,000, if she gets this one, which formula should we use? First one. So 10 times in the square root 105,000 plus reference point 105,000 minus 100,000. So this is final wealth, sorry. Final wealth minus reference point in the power of 0.88 plus.
Why 61?
No. This power will not change. This is the power, okay? That 61 is for this formula, all right? So this formula is nothing is going to change. So this lambda, how people are, putting weight on losses is given 2.25, okay? And these powers are given. And now we have to close the bracket here. Plus, there is 87% probability that her wealth is going to be 100,000. Which one should we apply? First one. Again, 10 times in the square root 100,000 plus 100,000 minus 100,000 in the power of 0.88. And if you calculate this one, students, it will be equal to 3,409. 3,409.4. Okay? This is the number that we get. Good. And now, in the case of, for sure, second case, weighting is, 1 is weighted as 1, okay? Because it's for sure. So now, we will calculate the second one. So for prospect 2, okay, second prospect. So now it's equal, there is 100% probability times 10 in the power of, final wealth is 100,250. Which formula should we use? First one, because it's greater than the reference point. Plus 100,250 minus 100,000 in the power of 0.88, okay, equal. If you calculate this one, it will give you the number of 3,295.1. 3,295.1. All right? So, should she agree?
No.
Will she agree? No. Why? Because from going to court, she is expecting higher utility than agreeing to get 250. Okay, the answer is here, no. She will not agree. Okay? She will not agree. I think, students, you understood, right? So that prospect A and B, you can apply this formula and calculate. You will get exactly the same answer. All right? Yes?
Why we are not using actual probability like 5% instead of 30%?
Because now we are considering people who are overweighting probabilities, okay? Overweighting probabilities.
I have a question. Why we didn't use the second formula and use the first formula?
Why didn't we use the second one? Okay, because 105,000 is greater than our reference point. Because our final wealth is greater than the reference point. 105 is greater than 100. So therefore we are applying this one. 100,000 is equal to 100,000. Okay? In this case. So therefore we are using this formula, okay?
I have a question.
Yes.
When you draw the graph, when the utility is a plus, she will not take a risk, but here she's taking a risk.
Because she is overweighting probabilities. She is now overweighting probabilities. So actually, students, if you are going to calculate this one with linear expected utility, expected utility from both is exactly same. 5% multiplied to 105,000 plus 95% times 100,000 will be equal to 100,000 to 150. So a person is in a dilemma. Which one should I choose, okay? So now we are considering way overweighting case. All right, good. So now, students, I'm going to take your attendance. It seems that students are more than in the lecture. I will quickly check your attendance, then I will give you a break, okay? So students, let's continue. Now it's now 3:10. I gave you more than 10 minutes break. So now, students, we have second exercise with some discussions. We have considered, students, in the financial markets how people behave, right? And we tried to explain it, people's behavior, with 3 models. The first one was equity premium puzzle. What was it, equity premium puzzle? Who can explain it to me? What was it, Maxim?
It was like the stocks which were like the securities which were had a very low rate of return. Like the riskless, they had a lower rate of return, but people actually chose them instead of the higher rate.
Okay, so that was the case, right? So look, according to the equity premium puzzle, even though the statistics shows, investing into risky assets, so stocks, right? Stocks was giving, and there are 2 options: investing into stocks or safe assets, right? Safe assets. So if there were these 2 options, whether to invest into stocks or safe assets, the statistics shows that most of the people, they prefer investing into which one? Safe assets, right? Safe assets. So the statistics shows most of the people, they prefer investing into safe assets. Why? Because investing into stocks, it has risk. But the statistics that almost 70 years of data, average, gains, return from investing into stocks and safe assets, it shows that average return from investing into stocks was 8%, while investing into safe assets was less than 1%. Average return. But people were still they were preferring investing into safe assets. Okay, that was the case. So, students, we are going to explain why people really they choose. Okay, why do they choose safe assets instead of stocks? Okay, so now I have told you during the lecture that if you do not understand this graph, we will be doing some calculations during the seminar. So students, now first thing is, now we have the prospect theory formula given. So if our final wealth is going to be greater than reference point, then we will use the first one, okay, or equal to. If it's going to be less, then we will use the second one. So now our given lambda is given, which is 2.25, okay, and our alpha and beta is given as 0.88. So now we are saying the monthly change is plus or minus 10. Here we are considering that a person invested $100, okay, $100 into stocks. Now, if next month, if there is gain, that gain is going to be $10 increase. If it's going to be loss, $10 loss. We are putting this condition just for the sake of calculation, okay? So now, in here, this data, so here, value of investment, we have invested $100, okay, in month 0, $100. So the next month there was increase, right? First month there was increase, which means that $100 became $110. Second month there was increase, so investment became 120. In the third month there was decrease, right? Which our investment became $10 less. So now you can see increase, increase, decrease, increase, increase, decrease, increase, 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 decrease, and so on. Now, first thing what we have to do, we have to write those changes. In the first ones, was that positive change?
Yes.
How much change? 10, right? 10. Second month? 10. Third month? Minus 10. Fourth month? Positive 10. Fifth one? Positive 10. Sixth one? Minus 10. 7? Positive. Positive. 9 also positive. 10? Negative. 11? Positive 10. 12? Negative 10. 13 positive, right? 14? 14 positive? Is it? Yes? Yes, 14 is also positive. 14 is also positive. 15 is negative. 16 is positive, 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 right? Now we have these values. So it tells it, now we have monthly data, okay? So that investment, our investment has increased by $10, $10, then decreased, increased, increased, decreased, and so on. All right. So now let's write down monthly value. Monthly value. We have invested $100. So in month one there was $10 increase. Our wealth became, our investment became 110. Second month, 20. Third month, because there was decrease, 110. 120, 130, 120, 130, 140, 150, 140, 150, 140, 150, 160, 150, 160, 170, and 180. Done. So now we have these values. What about, so now we are so people, okay, people are, in this case we are saying that I have invested every month. At the end of the month I'm checking. Oh, $10, good. $10, good. $10 loss, bad. I'm checking. So now in the second month, now we are saying that people are looking at their investment outcomes every 6 months. So now I'm not checking for the 6 months. I'm checking it at the end, so when after 6 months, okay? So now when I check after 6 months, my value will be 120. Once another 6 months passes, in month 12, my investment is 140. Another 6 months, now it is 180. Okay? So we have people, you know, they do not check, let's say, for 1 year. If it's going to be 1 year, it will be 140. Okay? That's the data that we have. Using this data, now we are going to apply our utility function. Okay, utility function. So now our utility function is given. Utility function is equal to, so our final wealth minus reference point in the power of 0.88, second one, minus minus 2.25, that lambda is given, right?
What's the lambda means here?
Lambda is this one. I have explained, right? This here, that lambda means this one. For example, if it's 1, okay, 1, let's say, because in front of this one it has 1, right? 1. So it means that if, you know, that $10 is going to make us, you know, for example, 1 time happy, right? Here, this 2.25, it means that $10 loss is going to make us 2.25 times unhappy. This lambda means this one. Okay? That's a good question. So lambda, so reference point minus final wells in the power of 0.88. So now we have it. So look, monthly utility. Now we have to find one monthly utility, okay? First one. So now I'm the person who checks my utility every month. At the end of the month, I'm checking what is my reference point? In month 1? 100. I invested 100. I'm expecting, so my reference point is 100. And now at the end of the month, my final wealth became 110. So now, which one I'm going to apply? First one or second one? First one. So now, I'm going to find the utility for months, first month. Okay, now, my final wealth is 110 minus 100 in the power of 0.88. If you calculate this one, students, it will be equal to 7.6. So let's make it calculate for 3 months only. In the second month, look, in the second month, my wealth became 120. What is my reference point? 110, because I already had that money. Okay? It will be reference point. So now, in the second month, my wealth is 120 minus 110 in the power of 0.88. It's again equal to 0.6. So, and what is interesting is the third one. Month 3, there was what? Reduction. Month 3. So now we have to use second formula. Why? Because our final wealth will be 110, but our reference point is 120. So, our lambda minus 2.25 times final wealth is 100, reference point is 120. Don't get confused, okay? So here, in the first one, final wealth minus reference point. In the second one, reference point minus wealth. If you are going to change the order, you cannot calculate it, because calculator cannot calculate the power of something minus with this power. You will see error, error, error. Okay? So therefore, be careful. Minus 110 in the power of 0.88. If you find this one, now it will give you the number of minus 17.1. So here, what does it mean? Here, $10 gain gives utility of 7.6. $10 loss causes this utility of 17.1. So if it causes like this one, but this causes this one. This is lambda, okay? I think now you understood this one. Done. So students, now here in each case, so now here 10, 10, 10, because $10 difference. So here utility, okay, utility. Here monthly, it will be 7.6, 7.6. Here negative 17.1, positive 7.6, 7.6, negative 17.1, 7.6, 7.6, 7.6, minus 17.1. Same, because 10, it will be same. 10, 10. Okay, exactly. You can calculate. Okay. So here 7.6 minus 17.1.
In exam, not necessary, yes, to calculate.
Huh?
In exam, not necessary, yes, not to calculate if it's the same.
If I'm giving to you this one, I will not ask you to calculate for 18 months. Because time is limited. I will tell you, calculate for the first 3 months. Enough. Okay, done. Minus 17.1, 7.6, 7.6, 7.6. Okay, done. And now, look. If it's monthly, do you remember, students, Richard Taylor and Bernard Z, when they have analyzed the data for almost 70 years. Okay, they have found when they compared those risky investing into risky assets and safe assets, when they said when it was short period, monthly, if it's monthly, okay, investment, so people are evaluation period is monthly. So like this one, monthly. If it was the case, people were, preferring safe assets. They were preferring safe assets, investing into safe assets. Why? Because of this one. Look. Now, this is utility of 0. This is positive utility. This is negative utility. Okay? Look. In the first month, look, there was $10 gain, right? So it caused utility of 7.6. Second month, there was another. So which means the utility level became 15.2. In the third month, there was $10 loss. This utility was large. You see? Now again, positive gain, sharp this utility. So if you are an investor and the people are investing every once, happy, third month you become very unhappy, stress. Next, again, happy, very unhappy. Then you will have problems with, blood pressure, heart attack, whatever. You decide not to invest. If it's annual or monthly. And now look, we are considering people their evaluation period is 6 months. So now, at the 6 months, if they don't check, they do not experience this type of this utility. Why? They are looking at the final number, 120. So now let's calculate for 6 months. 6 months. If you are going to make it utility of 6 months, okay, 6 months. Final wealth at the end of that 6 months is going to be 120. And what was what's the reference point here? 100. Yes? First month and the last 6 months. So now, which one should we apply? Which formula? First one. 120 minus 100 in the power of 0.88. If you calculate this one, what was that number? It's 13.96. Okay? Positive. So here at month 6, utility will be equal to 13.96. After 1 year, he is checking. Okay, again, now 140. The difference is 20. Utility is 13.96. So now, after in 18 months, he is doing now. The difference is here. It's his final wealth. His reference point is 140. 40 difference, then it is 25.69. All right?
Why you write 120 minus 100? But as you said, the reference was 100. So
Now, I have invested, right? I have invested $100. I know about this one. It's my money. And now I am checking at the end of the year, after 6 months. So now my final wealth is this one, and this is my reference point.
I thought it's the 5 months.
No, if it's monthly, it's different. Now it's 6 months. If it's annual, now if it's annual, students, if it's annual, now after 1 year I'm checking, now it's 140. My reference point was 100. So if you can apply this one, students, then you will get this number to be equal to 25.69. So students, what do we learn from here? Is it good if people invest? Is it good? It's always good, right? More investment, better for the economy. There will be more growth in the economy. So now, policy should be, for example, developed in such way. So then it's going to, or it should be framed in such way, if policymakers are able to do it, then if they can encourage people to look after or check the investments in a bit longer time, people's willingness to invest will be higher. Okay? That's saying what we have learned. And in Taylor's and in Bernardi, so if it was monthly, people preferring investing into safe assets. If it was annual, 1 year, annual. So they have seen that, that people, investing in both, return in both, that risky and safe is same, but it was longer, 18 months, okay, it was 18 months, then people, average return was higher in investing into risky assets. Longer. Okay, data showed this one. Yep.
For 1 year, it's 25.69, yes?
Yes.
Why it is 25.69 for 18 months?
Because here, when we checked, in this 6 months, right, in 12, it was 140. Now this is our reference point. Then after 6 months, it's 180. So the difference is 40. So if you apply that 40, will give you this number. And here too, I'm checking after 1 year, it's 140. But the reference is 100. Okay? So now it's 25.69. Okay, students, I think now it's clear. Next. Second exercise. So it was a bit not clear. In the book, it's not explained. I'm going to erase it. So students, what was the disposition effect? What was it?
The willingness of people to sell the stocks which are outperforming, right, as opposed to letting them grow.
Okay. According to disposition effect, it was the case that, for example, you have portfolio of investment. Okay, you have portfolio investment. You're investing into many projects, into many investment projects, and there were some of the investment projects they were gaining, okay, gaining. Some of them were losing. So the data shows that people are more willing to sell stocks which are on the gain side. And they are also selling the ones who are all loss side, but it's less. Disposition effect here, but on average when it was checked over, how those sold ones, the ones who were sold, which were gaining, and the ones who were sold, which were losing. On average, those which were gaining, in the future, they were further gaining. So people are selling, which are, there is higher chance of them further increase their, investment. Okay, wealth. So here, students, we are given data here. We will do it, and you will understand it nicely with this data. So, look. Let's suppose I'm an investor. I have invested into 10 projects, into 10. So to the first project, I have invested $10, second one 12, 14, 20, 12, 18, 20, 8, 16, $4. I have made these investments, okay? After after 1 year, for example, I am just checking how my investment projects are doing. When I check after 1 year, my first project is successful. My investment, that $10 investment became $14. Good. In the second one, positive. Third one, increase. Fourth one, decrease. So there is some loss. Here, loss. Here, gain, 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 loss, loss. I have invested into 10 projects. So these are the data, okay? So now, what we need, we have to write down, okay? So let me write down these numbers because we will use it. So my first project, second, third, fourth, fifth, 6, 7, 8, 9, 10. Just please tell me how much I gained from the first one. It's positive 4. Second one, positive 2. Positive 2. Minus 2. Minus 4. 6. Positive 7, right? Positive 10. Next one. Minus 4. Is it minus? Positive. Positive 4. Minus 2. And the last one? Minus 2. So now, from this 10, I have 1, 2, 3, 4, 5, 6 gains. And I have 1, 2, 3, 4 losses. So I have you know, risk diversification, right? You have learned. I have diversified my risk. So and when I diversified, there was 4 losses and I have 6 gains. Okay, that's the case. Good. And now, students, after 1 year, when I checked, and I decided to sell some of them, and I decided to sell this one. Which one is this one? Fourth one. Okay. I sold this one. I decided. Then I decided to sell that this investment project sold. I have sold this one. I have sold this one, and I have sold the last one. I just sold it. Okay. Good. And now, students, we know about this one. What we are asked to find is find proportion of gains realized. I have showed you a formula during the lecture. What was the formula like, students? Formula was for gains realized, right? For proportion of gains realized was equal to gains realized over gains realized plus paper gains. Paper gains. So now you should understand what gains realized is, and you should understand what is paper gain. You should know this one only. So look, now we will calculate it. Gains realized means the ones which we sold but they were gaining. So gains realized is now this one, and this one. All right? 7, 10, 4. Okay, gains realized. Good. Now we have 7 plus 10 plus 4 over 7 plus 10 plus 4. And now we are saying, what is paper gain? It is gain, but is it in the paper? I am not selling it. So the paper gains here, 4, 2, 3, right? So these are paper gains. Paper gains now here, plus 4 plus 2 plus 2 equal, if you calculate this one, pardon? Yeah, first 3. The ones which were not sold. They are in the paper. It shows gain, but I have not sold it. Okay? So it is equal to 0.72. 0.72. Okay, 0.72. Pardon?
The 6 numbers are below, right?
This is first one. Gains realized. Gains realized. Sold, which were gaining but sold. Gains realized. And this one is paper gain. Paper gain. They are gaining but they were not sold. Okay? And this is equal to this one. Next one. We have to find proportion of losses realized. Proportion of losses realized. Can you find it now? What's the formula? Losses realized over losses realized plus paper loss. Okay, paper loss. So now this is equal to sold
minus 2
minus 2 minus 2 over minus 2 in the paper losses minus 4 and minus 2 minus 4 and minus 2. Now if you calculate this one, it will give you the number of 0.4. 0.4. So now which one is greater? So now it shows that people are selling more with realized gains. Okay? Realized gains is selling realized gains more than loss realized. All right? Loss realized. They're gaining. So now, students, here, what is important is the last column. So now, I have sold it today, all right? And after 1 year or after 2 years, and that stock, the history of my stock, okay, they have checked how much, how well it is performing over time. On average, that stock that I have sold was growing by 1%. This one by 5%, this one by 20%, this one was decreasing, this one also decreasing. Okay? So now, we have to find that average, okay? On average, what happened with the ones which were gaining? So here I have these 3 cases, right? What was the average gain? Let me find with those gains. So gains average. Now, 1.05 plus 1.2 plus 0.97, right? Because these are 3 ones, they were in positive, okay? I am considering gain ones, these 3. And now, if we divide it, okay, by 3 average, it will give you 1.073. And now let's do it for losses. So now we have 1.01 and 0.8. So losses average, it's equal to 1.01 plus 0.8 over 2. This is equal to 905. So look, now it tells me the ones that I have sold, which were gaining, okay, which I have sold, on average, their return was 7.3%. But the ones that I have sold, but they were gained, the lost one, it was negative. So which I have sold, positive, okay, it was positive. I am selling it, but it was giving even more. And I am selling more the ones which were positive. So this is disposition effect. People are selling those stocks which are giving more. Okay? And the reason is why. For example, I have invested $100,000, okay? At the end of the year, I see that the stock price of mine became $1 million. $1 million. It's natural, okay? All people will think. It's natural, behavioral thing. Now, if there is 10-time increase, I think that there is no further increase. If tomorrow, the stock price, if it's going to go down, I will lose it. So therefore, they will be more willing to sell it. Okay, people behave like this one. But on average, it shows that the ones which were successful, they are further in the future also successful. So disposition effect, students, is this one. We are done. And the last one, what was ostrich effect?
Here in good news, make the investor to check the investment.
Okay, good. So students, when we discussed about equity premium puzzle, we said if it's monthly, if people they check it monthly, they will be a bit stay away from risky investments, right? But now here, according to ostrich effect, We are saying that people, when there is a good news from stock market, I'm hearing that stock values are going up. People are checking their, those stock performance quickly, more frequently. But in the case of when it goes down, people, they don't check it. They stay away. So look, students. Now, I will quickly finish the class. These are the results, okay? These are the results. Change in the number of fund lookups. Look, when there was bad news, which means the stock markets are going down, you can see that. So here, let's say I checked every month, okay? Which means that on average, in 1 year, I checked 12 times, right? On average. So students, now that's the average. Anything less than average, it is negative. Anything more, positive. Okay, that's the case. So that 0 means that average. Okay? So here you can see that when there was bad news, people they were not checking. It was negative. They were checking less than average. When there was neutral, which means that there was not increase or decrease in stock market. It was same. It means that if nothing changed, why should I check? So now here too it's negative. But you can see here when there was good news, stock value went up. People were more checking, probability of checking their stocks was positive and higher. Exactly when it was in Swedish bank, you can see bad news negative, neutral they were not checking. When there was good news, very significant check. Okay? So what does it mean? It means that students, those investors, in order not to experience stress, usually they check the outcomes when there is good news. Okay? Good news. Those good investors, they know it. Why should I check it? Anyway, it may cause me some stress, but maybe after 1 month, okay? That's what we mean, I think. And students, last one, with one word, we discussed about tax evasion, right? Tax evasion. We said that some people, they try to evade 100% of their tax. They do not report. Some of the people, they report 100%. Very good people. But we said in most of the cases, what do people practice? They try to, for example, report one part of the income and the remaining part they do not. It's mostly practice thing, right? And according to the standard economic model, which I have showed you during the lecture, students, what was the outcome? We said that maximum 50%, okay, up to maximum. If people pay up to 50%, it will increase their utility tax. Anything paying more than, reporting more than 50% of the income, more, it causes for people disutility. It was proven by standard economic model. But here the question is, why people pay 100%? Even though the standard economic model says up to 50% reporting, it will increase. Anything more than that one, it will make a person unhappy. Then why people are paying 100%? First one, explain in the case of decision weighting. So because time is over, students, even though there is 1% probability of being audited by tax officers, tax authorities, people see it as something very large. Okay? Not 1%, I think it's 20%. So therefore they are afraid they pay. This is one reason. Probability is low, but they're overweighting probabilities. Okay? Second one, explain in the case of reference points. So students, the ones who always pay, it is normal for them. Paying, it always makes them happy. And I explained it if people believe in government. For example, I am paying my taxes, and I really believe that my tax will be efficiently spent, which means that it will be good for my future, for my children's future, and my whole society. So any payment of tax, in this case, will increase my utility, okay? And the other one, discuss the likelihood of practicing tax evasion in the case of self-employed and working for a big company. So, one person is self-employed, the other one is working for a big company. The probability of tax evasion is going, in which case is going to be higher? In the case of self-employed. Why? What was the effect? Endowment effect, right? I am getting all money in my hand. Now I have it. I don't want to pay tax. But if I am working for a big company, I am getting all the money which is after tax. I don't have that ownership feeling, okay? So students, our class is over. Now you can go. Thank you.